Good morning, class, and welcome to this lesson on Circuit 7 resistivity. Today we will be able to describe how different factors affect the resistance of a resistor. So, depending on the type of material we have, certain materials will offer more resistance than other materials. Okay, that just makes sense. Like, for example, some materials are conductors, some are insulators. So the resistance will be affected by the material. But something else that will affect the resistance of a material is its length and its area. So we have this equation right here. Resistance is equal to the resistivity. This is the symbol rho, the Greek symbol rho, times length over area. Okay, so rho is a constant. Rho is a constant depending on the material. Constant based on material. So for example, if we were looking at aluminum, aluminum would be 2.82 times 10 to the negative eighth ohms per meter. This is the unit for resistivity, okay? That's just a constant, all right? And so this is going to be multiplied by the length over the area. So basically what this is telling us is that if we look at the equation here, length and resistance are directly related. So when length goes up, resistance goes up. And on the same note, area, the area of the material, and when I'm talking about area, we're typically talking about wires here. So the cross-sectional area of a wire, okay? If area goes up, resistance goes down. Down. Okay? So those are two factors that affect the resistance of a material. If we wanted to, resistance is equal to V over I. So we can set V over I equal to rho L over A, okay, depending on the question that we're trying to solve. But in general, we're looking at these two. So basically, what type of wires will conduct the most current? What type of wires will offer the least resistance? The least resistance. Well, if we look at our equation here, that basically is going to be wires that are short and fat. If they have a big area, the very thick wires, so big area means very thick wires that are very short are going to give us the least resistance. This is why if you're using power tools, and it's a pretty powerful power tool, and you have an extension cord, you want to have a fat extension cord if you have to extend it over a very long distance, because the longer the cord is, the more resistance is going to be to get power to the power tool. And so you need to have a fatter extension cord in order to kind of balance out the long extension cord. So those are the two things that are going to affect resistance. There is one more factor. There is an equation for it, and it is for temperature. I am not going to give you the equation for AP Physics B. If you need it, you can probably look it up. But in general, as temperature goes up, resistance goes up, okay? And as temperature goes down, resistance goes down. This is something that you just need to know conceptually, temperature and resistivity. The reason why, if I can give you an example, if we have electrons moving down a wire, right? So electrons are flowing down a wire, okay? Well, this wire is made up of a bunch of protons. Okay? The wire itself is made up of atoms that are made up of protons, right? Well, when temperature goes up, the atoms here, they vibrate more. We know this from kinetic theory and thermodynamics. Things that have higher temperature have more energy and they move more. There's more movement there. And so imagine this is the top of your head, walking through a crowd of people, okay? So you're walking through a crowd of people. Well, if everybody was standing still in this crowd of people here, okay, you would very easily be able to navigate your way through the crowd here, okay? Not a problem at all. But imagine trying to walk through the same crowd of people and everybody is running back and forth in place, okay? So they're just sprinting around back and forth, back and forth, back and forth. How much more difficult would it be to get to that crowd? It'd be more difficult. There would be more resistance to your current, to your flow. And that's the kind of thing that happens. These atoms move around so much because they're hot. The more they move around, the more resistance there is to electrons trying to flow through the wire. Okay, so it's the same concept. If you were trying to run through a crowd of people that are all moving around, that would be difficult to do. The same token, electrons have more difficulty flowing through a wire in which the protons are all vibrating back and forth because they're hotter. So, those are the three things that we're going to talk about with resistivity: temperature, length, and area.